All right. Hello, everyone. Today is the general meeting for the DS GT CLEF 2024 club. So the CLEF 2024 group is going to be competing in the conference, which is the Conference and Labs of the Evaluation Forum, which will be held this year in Grenoble, France in September. So we have roughly 25 people currently in our groups, split across 10 teams, and we're open to publish. So I'm glad everyone has been able to make it here to this general meeting. Hello to everyone who is watching this after the fact. And I'm super stoked to see everyone here. So let me share the agenda and let's go over what I have prepared. So can everyone see this? Yeah. Okay. So first thing is admin. Really, the first thing that should be here is DS GT dues. So if you're part of this group, take a moment to support the club that we're part of. Dues should be available through the link tree. You don't have to if you don't want to, but I think it's nice to be able to interact with the larger Georgia Tech community that's interested in data science. And while you're at it, join the Slack and join the Kaggle Clay channel, which is going to be our primary channel for communication across the team. The second thing I want to mention is that team leads should be handling onboarding starting this week, in particular around the infrastructure that we have set up. So at the next team meeting that you have, if you don't have one, you should be scheduling it ideally sometime next week. But what you'll want to do is you have access to these Google groups that are prefixed with ACL for access control list. So there's an ACL group for editing all the documents that are part of the drive. So once you add somebody to this group, they should be able to come in and edit the documents, take notes, etc. The second is to add them to the ACL group for GCP access. So there is an ACL group that contains DS GT, CLEF, and the particular lab. And so you'll want to add people to that GCP list. And then finally, you want to add people to the GitHub organization. So these three things are pretty important, and they should be done at the team meeting because otherwise managing all of that is really difficult. So I've tried to delegate the ability to manage people getting access to things through these mechanisms. So if you're confused, please reach out to me over Slack or in the channel. So yeah, that is what I have for admin. Anyone have any questions? I hear none. Okay, so let's move on to introductions. So there's quite a few of us here. So I'd like to limit it to the people who will be presenting today, which will be all the team leads for our labs and the tasks that we're participating in. So I'll go first. I'm Anthony. I'm a OMSCS student, and I'm currently studying in Georgia Tech Europe. So I'm in France. But I've been in the program since spring of 2022. And this is the third year that I'm going to be participating with the Data Science Club to submit something to the CLEF conference. So we already have 2 publications with the group. We've won $5,000 worth of prizes. And I'm really excited for this year because I've tried to significantly scale the number of people who can participate and the number of things that we're trying out. So that's me. Oh, also 8 years of professional experience doing data things and I'm based out of California. I'll pass things off to Murillo.
Hey, hi everybody. My name is Murilo. You probably notice I have an accent. So that's because I'm from Brazil. Actually in Brazil right now, which is pretty cool. I'm at my parents' house. I joined this group actually last year when I met Anthony at the OMSCS conference, and then I was part of the BirdCLEF or BirdCLEF group last year. And I'm gonna be leading the PlantCLEF and also gonna be involved with the BirdCLEF this year, and perhaps even helping the guys from SnakeCLEF and also FungiCLEF, since their solution is gonna be very similar to PlantCLEF. So yeah, very nice meeting everybody.
Pass it off to one of the other leads.
Okay, Ben.
All right, thanks, Murillo. So my name is Ben Ostrauer. This is my fifth semester at OMSDS. I started like Murillo in fall of 2022. I found Anthony because he reached out on the research EdSTEM board, and I always wanted to publish, and he kind of mentioned that, joining this group that was kind of the goal, and like you'd have the opportunity to do that. So I jumped on that immediately. This semester, I'll be leading two teams, the Touche image retrieval for arguments team and the Pan AI authorship detection team. So looking forward to get 2 publications out of that, and can't wait. So I guess I'll hand it off to Jennifer.
Thanks. I'm also an OMSCS student. I started, I think it was spring 2021. I can't really remember. I've been mostly working throughout doing it. Combination of data science and data analysis in finance. And more recently, I did an internship at Boeing, which was pretty cool. I will be leading the BioASQ team as well as participating in the GeoLifeCLEF. I also found Anthony through the EdSTEM research board. And yeah, super happy to have connected and excited to work with everybody. I'll pass it off to, I don't know who else is a team lead. Ritesh, I think you're also on. Sweet.
Thanks, Jennifer. Hey guys, my name is Ritesh. I'm of course as well an OMSCS student, started spring 22. This is my 6th semester, I think. Me and Anthony worked on one of the VIP courses last semester, and we're going to continue working. And that's how we came to know about the data science club and all of that stuff. And I was always interested in it, but never had any lead through. So thanks to Anthony, was able to get into it. And this is the first time I'm taking up this challenge. I'll be leading the iDPP challenge, Intelligent Disease Progression Prediction. I've always been interested in medical field, not being able to make it to a doctor position, but at least be able to do something in the medical field. So it'll be interesting. I have never worked with the data. I mean, I have worked with data, but never in a full-fledged form like this for a competition or a challenge. So it's going to be exciting. It's going to be exciting. I will hand it over to, let's see, who's David. I guess David is also lead. Yeah. We can't hear you, David. I'm not sure if it's just me, but.
Can you hear me now? I'm sorry.
Yeah, it's very light though, but.
Okay. Yeah, so my name is David Guesha. I'll be leading the eRisk team for this year. And I started OMSGS in spring 22, and I heard about the DS GT from in the STEMS board. So I'm happy to meet all of you guys and working with you guys, and hopefully one of you will be excited to join my team. Thank you.
Excellent. I think that is everyone. So there are far more people in this group than just these set of folks. But for the sake of time, we will move on to the next section. Make sure to say hello in the channel. And yeah, let's get started. Let me share my screen. And let me start this presentation. I have way too many things on my screen. Slideshow, presenter view. Does this look good to everyone?
Yes, sir.
Great. Okay. So today is the kickoff for the DS GT CLEF 2024 group. And so in this presentation, I'll talk a little bit about I'll introduce everyone to what this group is all about, a little bit about the conference, a little bit about the structure of our group, a little bit about the schedule of things. And then we'll have presentations about each of the labs that we're participating in. And then we'll talk a little bit about what we're going to do next meeting and have a little bit of time for questions, hopefully. So CLEF is the Conference and Labs of the Evaluation Forum. It's a information retrieval conference that has very heavy ties into both natural language processing and computer vision. So machine learning meets information retrieval, and it's a really interesting conference in my opinion. There's a couple of other related initiatives that you may or may not know. So SIG-IR is the ACM group that does information retrieval. And one of the very first information retrieval conferences was Sharp, which is very focused on these tasks where groups would submit into a competitive format to kind of collaboratively explore challenging problems. And they kind of kicked off this style of conference. There's various parts of these. Trek is North American based. CLEF is European based. NTCIR is East Asia based. FIRE, I believe, is South Asia. And Media Eval is a separate conference that is more media focused. So not CV or NLP, but I think video. There are a bunch of labs in CLEF. So CLEF is formed of a loosely connected set of organizations, and these organizations come together on a shared domain to organize these tasks and data sets. There are 15 of these labs, and each of these labs has their own kind of interesting challenge to present to everyone. So there's BioASQ, which is biomedical semantic indexing. There's Check That, which is checking factual information from news articles. There's Eloquent, which is new this year, which is all about generative language models and how to assess their quality. eRisk, which is for early risk prediction on the internet. I like to say it's DSM-4 meets NLP. Exist is for identifying sexism in social networks. iDPP is for predicting the progression of diseases. ImageCLEF is for everything image related. Joker is automated wordplay analysis, so having a machine understand puns. LifeCLEF is also co-listed with ImageCLEF, but it's very much focused on nature and biodiversity. Long eval is longitudinal performance of models, so I'm training a model now and evaluating it 6 months later, a year later. PAN is for telemetry, being able to detect authorship of various topics. So maybe figuring out if Shakespeare's plays were all made by Shakespeare. QCLEF is for the quantum computing Clay. This is a new one this year. And they have a quantum computer that is time shared that competitors will be able to use for clustering and feature selection. There's simple text, which is simplifying scientific texts, and Touche, which is argumentative systems. So being able to do pro and con using multimodal data, images and text. So those are all the labs that are part of the CLE conference, and the CLE conference runs on an academic cycle, or a yearly cycle at least, that generally follows the academic calendar. So there is the conference that happens every year in September. Last year it was in Greece. The year before it was in Italy. This coming year it's going to be in France, and that happens in September. There's a period after the conference where they're figuring out the organization of each of the labs, who's going to be leading the chairs, and all the stuff that happens in the background. Then the lab opens in January, and this starts the competition period. So team formation and figuring out what labs you're going to compete in, and actually making the submissions and doing the work of building these functional information retrieval systems. The competitions generally end in May or June. So there's between 4 and 6 months, depending on the lab. The paper deadline tends to be around June, and the camera ready paper deadline after the review process happens in July. So there's this whole cycle for CLE, and we've kind of gotten ahead of the pack by already forming teams and already having kind of good context into the problems that we're trying to solve and the ways that we're going to do them. The CLE conference is set up so that people who submit to CLE have a couple of months to polish up their papers and submit to ECIR, which is the European Conference on Information Retrieval. So this is very much a workshop heavy paper based on evaluation. ECIR is more of a normal conference that accepts papers on information retrieval. So that is the calendar cycle. A little bit about our group. We're under the data science at Georgia Tech club. There's 25 people spread across 10 teams. And the big goal of this group, and our main goal, is to publish. So the way that we've done this is I've identified people who are strongly interested in publishing, have the capacity and bandwidth to kind of organize smaller teams. And some of us are aligned by taking 8903, which is a special projects course, which means that the grade is contingent on completing a system and writing that paper. So we have some people who were with us through the fall for the interest group. Many of them are now team leads. And I feel very confident in our ability to publish. I think it's going to be a good and productive semester. So really looking forward to that. I think the structure of the group really helps with that. As for our schedule, there are a couple things that are planned. So we're going to have the general meeting. So this happens once a month for an hour on the second Thursdays of the month. And this is for all the teams to come back together and to share progress and to share context on the problems that they've been solving. I'm hoping that this is a good way for everyone to kind of get a sense of what everyone else is doing and to be able to take advantage of all the different people that we have here and all the different skills that collectively we have. So this meeting, January, is really an introduction to see all the teams that are here and to kind of get a sense of the direction for the projects. Next month in February, it's going to be a progress presentation on the data processing, like downloading the data, looking at the data, and really presenting some initial exploratory results from that. Maybe some folks will have a baseline model, maybe not, but everyone should have some deliverable for this next meeting. In March, we'll do progress presentations on baseline submissions and modeling. So at this stage, the general direction of the solution should be pretty fixed. The initial model should be done, and teams should be really looking at how to differentiate their solution from other solutions that have been submitted in the past. And our final meeting will be in April, 2 weeks before finals, I believe. And this is going to be our final presentation. And at this point, we should have working note drafts. But I believe this period is probably going to be pretty heavy in terms of active development. So it'll really just be a way for us to kind of wrap things up. We may or may not have an extra meeting. Depends. We might just wait until the fall to really see all those. The second component of our group are the team meetings. So these are weekly meetings that are organized by the team leads. These are 30 to 45 minutes, and they're really meant for project management and status updates. So who's doing what, and what is the progress that you've done in this last week. So I'm expecting weekly attendance from everyone who is part of the group, because communication is very important when you're working asynchronously. There have been times where people have been non-communicative in the previous groups that I've been, and it really helps to know that people are engaged with the project. And even if you haven't done anything, it's good to explicitly say that in a synchronous way. I anticipate most of our technical work is going to happen asynchronously, either in pairs or individually. So if you're not familiar with this style of meeting, this is very typical of remote work. So I believe, since most of us have, I'd say a large majority of us actually have industry experience. So I'm not too worried about this structure, but that's the next component, which is team meetings. I'm going to try to hold coffee or office hours where I'll be available at a fixed time. I'm hoping twice a week, one in the morning and one in the afternoon, to be available for Asia and North America. And if no one shows up, I'll just be working on clay stuff. So it really doubles as a way for me to time box some stuff. And yeah, you can just drop in and we can talk about anything. Just if you want to learn more about what I'm doing in France, if you want to talk more about the clay conference or some technical idea, I'm free to just talk. And finally, there's the group hack sessions. I'm anticipating near the end of the semester, it's gonna be busy. And I'm hoping to hold a couple of these 8-hour sessions where everyone just comes into the Zoom room and works together. We did this last year for BirdCLEF, and it was successful, and it was really useful. So I'm hoping that is a valuable structured piece of time. I want to talk about an example team schedule. This is kind of high level what is being done week to week. Not every team has something like this, but this is a good frame of reference for how you should be thinking about time. There is 16 weeks in the semester, and 16 weeks is not a lot of time to build something. So you have to know what you're doing, and you need to execute efficiently. So in this schedule, we have 4 weeks for doing data processing and data engineering. So you want to take any data that you have in like CSV files and XML files or images, and you want to convert that into a format that is going to be efficient for inference, and it's going to be efficient for data retrieval, because CSV files aren't super great for querying. Neither are hundreds of thousands of images in individual files. So you want to be able to partition these into batches, make it efficient for whatever processing. I anticipate this to take about a month. This next section is from weeks 5 to I think just before spring break. So this is 7-ish weeks of modeling. For the GeoLifeCLEF competition, we have a couple of interesting models we want to take a look at. There's this learning to rank model. There's these Gaussian mixture models. There's TileDevec, which is an unsupervised embedding model. And there's some stuff for time series data. So we have this learning of time series dynamics, spring break, and then we have some engineering at this. So we've submitted the baseline. We're building this pipeline, and this is probably going to take another 4 to 5 weeks. So after spring break, it's really going to be kind of heavy on the like implement and submit things and tune them. And then the working notes will just kind of be done at the end of the semester. Thankfully, it aligns pretty well. So this is an example, like the team schedule. It's useful just to kind of plan out what's going to be done on a week-to-week basis. And this should hopefully give you an idea of the work that is going to be entailed in each of the teams if you're part of a team. So with that, the team leads for here's a list of all the team leads. So I am mostly involved in all things like play. Marilla will be leading the PlantCLEF competition, which is very challenging at scale, which is why it's not, I can't do everything. Ben is going to be part of PAN, the telemetry competition, and Touche. Ritesh is iDPP, David is eRisk, and Jen is BioASQ. So with that, I'd like to go over the lab overviews, and the team lead for each individual one will present their thing. So first, let's talk about BirdCLEF. BirdCLEF is the competition that kind of started this all. So it is running yet again this year, and I'm pretty excited about it. So the goal is to help identify bird species at scale for biodiversity conservation. So bird species are kind of disappearing quickly across the globe, and it would be useful to be able to do some sort of census of birds. So the task here is to take soundscape audio, which might be 10 minutes of audio, and find for each 5-second interval if there's a bird call, and if there's a bird call, what species is it? For last year's competition, it was about 250 species with about 17,000 audio recordings of different lengths, but totaling 200 hours. And our approach was transfer learning with semi-supervised data annotation, which means using a pre-trained model to transform the audio into some vector space. And then once we have it in that vector space, to do the supervision problem. One of the things is that we don't have labels for all this data. So we have to build those labels. And the way that we do that is we use existing models to kind of generate labels. And we go through a process to filter labels that are consistent with our understanding of the data. So first is the embeddings. So embeddings take audio data, you chunk it up, and then you transform it into some space, and you can plot those points in space, and they cluster really well. So that means that there's some knowledge in the model that's being imparted on the data as it gets transformed through this model. And this helped validate the idea that we could use existing models and learn it for new species. We built this whole pipeline, which we will hopefully use next year. But this kind of just shows how much engineering work is actually involved when building these information retrieval systems. I think the research directions for this year are going to be focused on kind of tightening up what we did last year. So more rigorous evaluation of the semi-supervised labeling process, trying some more embedding models. So the Meta has AudioGen, there's the Whisper model from OpenAI, there's deep speech. These are all focused on human speech, but maybe some of these models learn a space that are able to distinguish different bird calls. Who knows? I'm also interested in dynamics of time series. So I think you can learn some interesting things using linearized versions of the data. So that might be cool. And finally, sequence models, so like transformers and whatnot, to be able to learn what these optimal set of classes are from sequences of embeddings. The next competition is GeoLifeCLEF. So this is information retrieval for remote sensing data. So there's a bunch of data points on a map, and we need to use those data points to figure out the distribution of different plant species. They give us images, satellite imagery. They give us raster data with elevation, temperature, and there's some time series in here. When going through these problems, I mentioned solution sketches, and you'll hear solution sketches in the future. They could be a literal sketch, but really it's an approach to the problem. And so the approach to this problem is we're going to be using TileDevec, which is for unsupervised learning of the data, this Koopman estimation to learn linearized dynamics from the time series, learning to rank for this ordinal regression, which is interesting because we only have the presence of species, and we don't have what species aren't present. So learning an order to the species is useful. And then there's this Gaussian mixture model that might be useful to actually do the kernel density estimation. So to go to, there might be species in this area, to there might be species in this area on a map. Next, PlantCLEF. Give it to Murillo.
Yeah, sure. Thanks, Anthony. So I don't have really a sketch of the proposed solution, but I can definitely talk to you about what PlantCLEF is and what we're going to be doing. So PlantCLEF is basically a multi-class classification problem, and we're going to be trying to identify 80,000 different plant species over 4 million images. So that's quite a lot. There's mainly two data sets. There's at least last year, there was a trusted data set with almost 3 million images and 80,000 different plant species. That's 160 gigabytes of data. There's also a web data set, million images, 57,000 plant species, and 92 gigs of data. So both combined, we have roughly more than 250 gigabytes of data, just images. So that's a very difficult problem. Before I dive into our proposed solution, just talk about what has been done last year and what people have been doing for this particular problem. I believe the team that won the competition last year was a lab in South Korea, and they trained 16 RTX 3090 GPUs for 3 months to try to solve this problem. We do not have that amount of computational power and resources, so we're going to take a different approach. So we're going to try to leverage Spark to distribute the process of data across clusters. That makes very nice for like data analysis and data processing. And we're also going to use PyTorch for the deep learning model training stuff, because we're actually going to be using embedding. So how is this going to work? Images are high dimensional data. We're going to transform those into lower dimensional spaces, which is like embeddings, which really makes it easier to process and analyze all of those data, and also train those machine learning algorithms. So the way how we do that, embeddings are usually obtained from models that have been pre-trained on larger data sets. So we're going to be using the Dino V2 model that was developed by Meta. Dino means, I think it means dissecting vision transformers. So it's a vision transformer model used for computer vision. And so, yeah, that's basically what we're going to be doing. We're going to be using the model to extract features from the images. So basically, when you pass an image through this model, it generates embeddings, and which, like Anthony said, are basically condensed representations of the main features of the image. And they kind of capture like the essence of the image, let's say. And we're going to be using those to classify those plants, and hopefully is gonna give us good results. Not sure if it's gonna be comparable to training 16 GPUs for 3 months, but we're gonna try it. And also another thing that they found was that more images was better than like really good pre-trained models. So I think we're gonna actually do a lot of data pre-processing and data augmentation and just try to get more data or make our data better for this problem. So, yep. Next slide, I think I added like a little snippet of what oh, never mind.
Yep.
I updated the slide, but it's okay.
For sure. Well, thanks, Merle. So next is going to be me. So these next two are actually really similar to PlantCLEF. There's SnakeCLEF and there's FungiCLEF. SnakeCLEF is to identify snake species from images. So there's 1.7 thousand snake species across roughly 60 gigabytes of training data. I don't know exactly how many images those are. I want to say it's between like 200 and 300,000. And a 5 gigabyte validation test data set. And one of the challenging things about snake species is that there's all sorts of different snake species that have color variations that are supposed to signal, I am dangerous, don't touch me. And other snake species that aren't venomous will use that coloration as a survival mechanism. So one of the purposes of the task is to be able to identify snake species and whether they're poisonous or not. And that last bit of whether it's venomous or not is one of the things that makes this challenge challenging. And the next is very similar. It's about fungus instead of snakes, but this idea of whether the identified mushroom is edible or poisonous plays a big role in the evaluation criteria. So this uses the Danish fungi 2020 data set, which has 300,000 images with 1.6 thousand species. It also has labels and metadata, which is different from SnakeCLEF. So this information is interesting because you can build multimodal models that incorporate both the tabular data and the image data. And there's a couple of interesting ideas that I think were applicable to FungiCLEF. Of course, the transfer learning with Dino V2, but this idea of multimodal data, other teams have used CLIP, which is text models that are conditioned on images. I think contrastive learning might be a great way of being able to do this one-shot learning. But these are some examples of mushrooms that are part of the data set. And so I think these two LifeCLEF competitions, SnakeCLEF and FungiCLEF, alongside PlantCLEF, are going to be kind of an interesting group. So next is Touche. So I'll hand it over to Ben.
Thanks, Anthony. So I'm leading the Touche image retrieval for arguments task. It's a competition that's been around in the Touche competition for a while. It actually has several different subtasks. The one we're focused on is like a specific image retrieval for arguments. And what that is they give you several different queries from a Google search, and they return hundreds of, possibly thousands of images from that Google image search. And your job is to then, given these Google queries, take from this collected crawl of images and rank them as most relevant, on topic, and whether it's pro or con for this argument. And they evaluate you on this like precision at K metric. So to the right here, I have like kind of an example of a query and an image that would be retrieved from Google. So this is like an example from a prior competition. The query was, politicians have no right to privacy fact check. That's verbatim. It's weird, but I didn't type that weird. But you can kind of see the image to the right. Like it's graphical. It's on topic. It doesn't really have a stance though, so that's part of it. Because you can see that like it mentions fact checkers for politicians, but it doesn't really have like a pro or con stance. And as I was saying before, this data set is like very, very large. It's been around for a few years, this competition. Every year, the data set has actually grown pretty substantially. They haven't released this year's data set, but last year's was over a terabyte, just because they give you so much information. They gave like 50,000 crawled images, but they also give like the web page from the text that it's retrieved on, the XPath. I think they've started to provide like Google Vision API, so it'll tell you like what degree of certainty that they see, like 2 chairs or a table, or there's like 100 different objects that they put in there. And I'm going to work on this along with 2 other team members, Ashley, who's here, and Emma, who's unfortunately not. But on the next slide, we kind of dive into the solution sketch. So as I've said, this is not a new competition. Our approach right now is to kind of draw elements from past solutions and unify them into a single neural model. So to the right here is like a previous solution sketch from a different team in the past few years. But you can kind of see like it's very sequential in that you're going to give like the website text, the title, and the image, and you're going to sort of embed these in the lower dimensions before making like this index, this space that you can kind of then take your query, put it also into the space, and then retrieve, you know, the 10 closest images that would live in this space from this query. So that's going to involve things like image clustering. You're going to have to do some natural language processing on the web page and the image text. You're going to have to do some stance analysis on the process text. So I've seen some teams, you know, look for words closest to the image in the XPath and try to look at for like positive and negative words, or they might write some query expansions where, for instance, you might have a query that's like, is nuclear power good or bad? And they'll write, you know, 5 or 10 different rewordings of that phrase, and then try and look for similar wording in the text. That would be query expansion. And then obviously there's a ranking mechanism for retrieved results. So you might return maybe 100 results, then you need to cut that down to 10. So how could you do that with a re-ranking mechanism for, you know, what's the 10 most on topic, what's the 10 pros, 10 cons, and things like that. So I think the PAN topic is on the next slide. So I'm also leading the PAN competition. This is a new competition. It's just come out this year, but it's very relevant. They give you like a short blurb of text, like it's a poem, it's a news, weather, stock report, sports report, and they're going to this lab is actually in collaboration with the Eloquent Lab, which they would be building small text like this, and the Eloquent Lab will use like this LLM AI author to write these blurbs of text and then feed it alongside with like the human written equivalent. And then the PAN lab now has to actually discriminate between this is a human written text and this is a AI authored text. So I'm leading this team along with Abhinav, who's here today, Jack and Shinar. They couldn't make it, but they're you know, on-campus students. So on the next slide, we kind of dive into the solution sketch. So I wrote this last week, but and we've had our team meeting on Tuesday, and everyone had some really good insight and a little more concrete way forward. But right now, this is a project that I've done in the past for EduTech. My approach kind of combined sort of like how we're planning Touche, several different elements from different papers into like a single unified neural solution. So I've seen papers, you know, have this like statistically augmented neural network of, you know, finding the word count, the unique words, the zips distribution of like the top frequent words, punctuation distribution, stop word ratio, all that, feed it into some, shallow multi-layer perceptron, and then classify the text. There's also different sort of input data that you could use, like coherence, which tries to model like how well the text follows itself. So this is kind of a cool thing that I was hoping to implement this semester. To the right here, I have this kind of image from a paper that sort of talked about like building this graphical neural network for factual coherence. And it effectively what it did is it would take out like it would use named entity recognition to find like all the nouns and per people, places, things in a text, build like a graph of these entities, and use like sentence links and paragraph links to kind of find a way to make sure that the text doesn't really diverge from itself, in like a incoherent way. I thought it was cool, and I think that that's something that we would definitely seek to add. And finally, this is from another paper, an abstractive summarization of the text, which is basically like you have a text that you want to summarize, but not just extracting words from the text. So you kind of use sort of new language that you didn't read from the document. And I've seen papers use this as another input into detecting like AI authorship. So we're hoping to kind of combine these along with some other approaches that we're thinking about to, get a good score and to get a publication in.
Great. Next we have Touche.
All right, turn on my camera as well. You guys can hear me fine?
Yep.
Okay. All right. So as mentioned before, I'll be working on and leading the team for iDPP, which is Intelligent Disease Progress Prediction. It is to design and develop an evaluation infrastructure for AI algorithms, which are basically the challenge targets primarily two neurological diseases, ALS and MS. ALS is basically amyotrophic lateral sclerosis, and MS is multiple sclerosis. Both of these are neurological diseases, which essentially affects your brain and the spinal cord area, and they are chronic in the sense the condition of the patient kind of worsens over a period of time. So the objective over here is to try to get the sensor data. You will be given the sensor data from the data set, but the objective is to use the sensor data and predict a score, which is called ALS FRS score, which is somewhat subjective in the sense that doctors would look at the sensor data and say, all right, I'll give the ALS score as 25 for this patient and 45 for some other patient and whatnot. So it's very subjective. There is no concrete way. There's no formula behind it. So one of the tasks for this challenge is to use the given sensor data and try to see if we can predict the ALS FRS score. The sensor data consists of three main items. One is the sensory data coming from your mouth, like talking, swallowing, like bulbar functions. Another one is your fine and gross motor skills, like walking, chopping, hygiene, combing your hair, and stuff like that. And another one is, what's the other one? The third one is the respiratory ability of breathing, how hard, how easy you're breathing, able to sleep while sleeping, while talking, while running and walking. All the sensor data will be provided, and we don't have the data set yet. So I'm assuming that it will be provided in a way that will be easier to use them and predict the ALS score from that. The sensor data, this is at the data set is at this intersection of probably a time series data versus longitudinal data, because the sensor data is taken almost every day on the patients, but the ALSR score assessed by the doctors is usually once in 3 months, every 3 months. So there will be some mapping might have to be done between the data, sensor data, and the score that will be provided. This year there are 3 tasks, as we can see over here. We will be primarily focusing on task 1, and maybe we can get to task 2, but our focus is going to be primarily task 1. And the approach that me and other folks from the team have thought about is, if you Anthony, can you go to the next slide? Sorry, I have a pen written sketch from, I did it over the past few days. So as I mentioned before, that on the left-hand side, we have the data coming in, the Barber function, the fine gross and motor skill, and the respiratory functions. And we'll be given the ALSR score for X number of patients. And what we are planning to do is, upon reading some literature online, what I found out that the Barber function, or the sensor data from the Barber functions, it may be audio files. It may not be truly numeric files. I mean, numeric files would be easier to work with, but yeah, if it's audio file, then maybe pre-processing needed for the audio files to be converted to some kind of numerical format. And in medical field, there is a term called censorship of the data, where some of the patients may not see any event happening until the observation period is done. So that has to be accounted as well in our pre-processing. And if any and of course there will be some normalization needed, because all the sensor data will be of different scales, because there are different sensor data. Accelerometer is one of them, and then audio would be one of the other ones. And there'll be some feature engineering we might have to end up doing. Next, for model, at this point, we have discussed, and there is all kinds of areas that we are trying to explore. One of the objectives that we have is we want to start with something very baseline, very simple model, like one of the models suggested was linear mixed effects, which kind of takes into effect the time series or the longitudinal nature of the data. And from there on, we have a baseline, and we can build up on top of it with more complex models to see how much we can improve from the baseline. Some of the suggested ones, or some of the ones that I found online in the literature, were modifying the time series based data to adapt, modifying the tree based data to adapt them to time series. And eventually, obviously, we have the deep learning, the neural networks, and try to see if we can use we'll be using PyTorch as well, again over here. But yeah, so those are some of the models that we think could be valuable, and we can try them. And eventually, with these models, we have to actually, the ALSR score, the overall score is actually an aggregation of all the three functions. So all the three major functions that I told in the beginning, the Barber, fine motor, and respiratory, they all give their individual scores from their own data. And that on the three data that we get is aggregated to get the final ALSR score. So it is like three problems in one. We are kind of predicting all of these three values, and then we are getting the aggregate score out of it. So that's the last block down at the bottom right. We says that we have to predict the individual components of the score, and then eventually we get the aggregate score for the data. So anyway, so that's what iDPP is about. I will be helped by three other folks. Anthony is going to be one of them. Shashank is going to be here. I think Shashank's here already, and Alex. So all four of us will be brainstorming. This is my first time, so I'll be learning a lot while doing it. So it's going to be fun.
Thanks, Pritesh. Next, we have David with eRisk.
Thank you. eRisk is a lab instituted to foster the development of early risk systems. We're going to be working with data sets pulled from the website Reddit. They specifically have terms of service that they allow people to use their data for research purposes. The main goal is to create systems to prevent people to harm themselves or to detect antisocial behaviors in social media. This year we have three tasks. We have detection of depression symptoms, and so basically we have a collection of texts, and we're gonna use that to answer a questionnaire called the BDI2. That's a questionnaire used to rank depression symptoms. The second task is an early detection system for symptoms and anorexia. So we're gonna have a collection of sentences with positive or negative examples of users that claim to have anorexia, and the goal is to create a system that will pull a sequential series of texts and over time, and the goal is to create a flag or raise a flag whenever a text pops up and the system detects that is a positive case of anorexia. And there's also scoring so basically the system penalizes you the latest the more time you take to report that the user has anorexia, the system will penalize you. So it's like there's some trade-offs there that we have to work with. The third task is similar to the first one. There's also a questionnaire that needs to be answered that has symptoms of or eating disorders rather. What I like about this lab in particular is because that most of the teams that I read that submitted papers, they took very different approaches to solve the problem, and we have support virtual machines, we have large language models and neural networks, among others, to solve this problem. So there's like opportunities to explore. And this is like a solution sketch that I did mostly for task 1. So we're gonna have our sentences, and we're gonna do data preprocessing using NLTK or any other library to remove sentences or to reduce the data set. And we're gonna use some sort of transformer model like BERT or many others that are out there to pull the vectors or embeddings. And finally, along that, we're gonna do transformers on the BDL questionnaire and pull the embeddings, and the final step is doing cosine similarity between the vectors, and the system has to return a classification score between for similarity between the two vectors. So that's roughly for what we're doing for task 1. The team right now, we have 3 people. It's myself, Sandra, and Arian. And that's it.
Great. Thanks, David. And finally, we have BioASQ. So Jen?
Yes, so to introduce this task, it's commonly known that biomedical knowledge is pretty scattered across many databases, some public, some private, and often biomedical experts really struggle to find like the specialized information that they need. So one way to address this is to create some sort of information system in order to allow experts to very easily retrieve answers to questions they're looking for. And one way to do this is through semantic indexing. Currently, that's generally a manual process, and you would need automation for this to be in any way scalable. And BioASQ is really aiming to essentially improve biomedical semantic indexing and question answering systems. And they're presenting us with, I think it's 4 different tasks that contribute to this problem statement. There's 2 main tasks that have a lot of information on them and have been sort of repeats over the years, and 2 other more new tasks that don't have a ton of information on them right now, but I'll just briefly touch on them as well. So the first one is what's known as task 12B. The way that this will work is there will be benchmark data sets, and they'll have both development and test questions in English, along with an answer key or like reference answers. And these data sets are going to be constructed by medical experts in Europe. And the way it's going to be broken up is in 2 phases. The first phase, BioASQ will release questions from these data sets. And then the participating teams will have to create a system that can respond with relevant articles and snippets. And they're going to give us those article repositories that the system can choose from. Phase B will have BioASQ release both the questions and the correct articles and snippets. And they'll be looking to have the teams respond with exact answers for like fact-based questions like who was XYZ, as well as what they call ideal answers, which are more like paragraph size summaries. And these will be both in English. So that's task 12B. They also have a task called Task Synergy. It's slightly different. They will have a number of questions that are going to be posed by their group of experts. And then we'll have to provide answers from a PubMed data set that they have versioned off for it. And the way that it's structured is in different rounds. So the first round, we will just have the questions and no correct answers. It's actually already starting. So the first round is 2 weeks and it started on Monday. In the subsequent rounds, we will be given answers that have been selected by a group of experts from the answers that we've provided in round 1. And so you can see that the answers that were given are just answers that have been selected from previous rounds. And you don't have to participate in all the rounds if you don't want to. You can participate in any of them or none of them. And I'd highlight what makes this task a little bit different from task 12B is that you receive both negative and positive feedback based on responses from previous rounds. And also in this task, organizations experts are not composing answers themselves. The answers are just being selected from participant answers. And then there's a couple other tasks that I thought I would mention. They're not on the slides, but one of them is called multi-cardio NER. It's just detecting diseases, symptoms, and procedures from a data set. Don't have too much information on that yet. And then another one is called Task Biome, and that is focused on nested named entity recognition. And that's also looking at doing that from a PubMed abstract. But in any case, I'll just go through a very simple solution sketch. We haven't had a team meeting yet, so this is probably going to change quite a bit. But the way I can envision a very simple solution to this is just starting by processing the question and just tokenizing the question and going through different NLP processes like stemming, lemmatization, and just overall reducing the dimensionality of the data and making that easier. And then just going through different information retrieval systems, like there's TIFF-DIFF, cosine similarity, BERT embeddings, and possibly even things that are much more advanced than that, depending on what the team wants to look at. And then once we have that information, we can generate relevant snippets from them, and that could possibly be done using a pre-trained LLM model, and then fine-tuning it as well. Similarly, for phase B, providing exact answers could be done through things like named entity recognition, as well as ideal answer generation is much more similar to what you would imagine like a ChatGPT responding with summaries that are often done through maybe open source or pre-trained LLMs. And then one thing that I was just looking at today is called retrieval augmented generation. And that's just something that I've recently discovered. It's the process of optimizing like the output of a large language model and have it like reference a more authoritative knowledge base before generating a response. So I think that could be an interesting way of looking at providing answers from a data set that's already given, specifically something like that's very specific, like a biomedical database. So yeah, the team members I think might be increasing for this, but right now I believe it's myself, Hang, Rusty, Dywick, and Akul who might be joining the team. But yeah, I think open to more members as well.
Great, thank you, Jen. So I'll talk a little bit about the next meeting. We are over time by 10 minutes. So I apologize if any of you have somewhere else to go. But we will talk a little bit about the next meeting and we'll have some time for questions. And that is what we have scheduled. So for next meeting, this is going to be a month from now. So second week of February. One of the things that I want to have done is onboarding material for getting access to computing resources. So this is going to include a VM in GCP that teams can use for doing data processing. There's some interesting tools within GCP So if you have ideas for things that you want to try that won't break the bank, then I'm totally happy to support it. But one of the things I'm looking at is the serverless Spark service, which I think will be super cool. So there's going to be some onboarding material for that. I might also include other ways of doing compute. So things like Colab, maybe Kaggle. There's various ways of being able to actually compute things. I think by next meeting, there's some logistical goals that I've already mentioned at the beginning of the meeting, but everyone should be in a scheduled weekly meeting. Everyone should be in an ACL group, and everyone should be in GitHub. And everyone should test their access to things. Just making sure that you're all set up will make it easier for you to get started and to play around with the problem. And the next meeting is going to be focused on technical milestones from everyone. So this is going to be a well-defined solution sketch. Ideally, you've gone through the data, you've looked at it, you've gone through the literature, and you've looked at things. If you already have a well-defined solution sketch, then this will be easy. But you'll also want to do data set processing, kind of report on what that looks like, as well as any sort of exploratory data analysis. So next meeting will be very similar to this one, hopefully within time. But I think it'll be super interesting to just see what we have from our teams. We have everything from computer vision over to NLP across a variety of different domains. We have biodiversity things, we have medical, biomedical topics. So I think this will be pretty interesting to see how everyone progresses. And so with that, I'll leave the floor open to questions. Yeah, any questions from the room?
Anthony, you planning to have some kind of a 101 for using the cloud services? Because
Yeah.
I had never
Yeah,
used them, just to be frankly honest. So I don't want to go in there, monkey around, and click something that I'm not supposed to. Types. So yeah, if just a little 101. Okay, here is how you start the application. These are the places that are of interest that you should be usually going to, and this is how you would upload your data or request models or whatnot, right? If you can just give like 15-20 minute thing record it so that we can kind of review it when we forget later on down the line, that would be great.
Yeah, that is a good point. That's one of the onboarding materials that I want to add. So I've asked Marilla to record kind of like, how do you get access to GCP and run a thing in Jupyter?
Right.
But I can also record some, like, be careful with resources. This is like what the
Right.
GCP interface looks like. Here's like what a good project layout looks like, amongst other things. So I can do that. And if you want to schedule one-on-one time with me, I do have a booking page. I'll link it in the index page maybe, and I'll just have 30-minute time slots that you can book. I've tried to
once I see the video. Sorry, go ahead.
Yeah, I've tried to make my schedule on my calendar very explicit. So you should be able to like book a time and it'll be okay. Yeah.
Okay. Yeah, I mean, I was just telling that once you have the video available or the tutorial available, then maybe if I have questions, then I can send a schedule something with you. Yeah.
Yeah, for sure.
But yeah. And you I think we discussed this long back, I guess, but you're probably going to somehow keep track of all the billing thing that you probably incur, because I mean, at least from my side, we will want to contribute to that, so we also know how much it costs in future.
Yeah,
to use those services.
GCP is very good about billing.
Okay.
Making reporting on billing. So I'll be transparent. I'll post the billing report at the end of the month, just so you can all get a sense of like how much this costs. Again, I'm happy to put the bill. I will probably put up a page so you can chip in if you want. But yeah, like ideally, like the solutions that are made aren't running 16 GPUs for 3 months, like 24/7. Don't do that.
Yeah. Yeah, for sure. Thanks, man.
Yep. Any other questions? All right. If there aren't any more questions, then this is meeting adjourned. I'll hang around for a bit if you want to talk, but otherwise, thank you for coming to today's meeting.